Hello everyone, welcome to my YouTube channel CAD Engineer. In this video, we are going to see static structural analysis of a crane apparatus in ANSYS Workbench. Now let's see the example. In this example, we have a crane apparatus which have a main body and two welded roller parts. All the materials for this example we are considering structural steel, where we take the tensile yield strength of 250 megapascal and we are defining the force of 28,000 Newton in y direction for each roller and calculating the total deformation and stress on the model. Let's start. So we'll go to analysis system here and we'll select static structure, double click on that. Now we are going to import the model. We'll click on geometry, right click and go to import geometry, browse, we'll select the part and open. To see the model, we'll double click on the geometry and open the model. So here we have our model. Now we can see we have this main part body and we have two rollers are there. Now we are going to close the space claim window. We'll go to file and we'll say exit space claim. Now let's verify the material detail. For that we'll go to engineering data. So here we can see we have structural steel material. So here we have to take a tensile yield strength for 250 megapascal. So we can set to 250 megapascal. We can see that. Now we can close this. Now we'll go to mechanical window. For that we'll double click on the model. So at the bottom we can see here we have our mechanical windows open. We can click and we can see the model is loading here now. So it will take little time to load the model. We can see that model is loaded successfully. Now we are going to define the details one by one. So first of all we'll verify the material for the geometry. So as per the problem we are using structural steel for all the parts. So here we can see the assignment of material is structural steel. For roller also we have structural steel. Now we are going to generate a mesh. Let me generate a mesh. Now one more thing, we have to define a connection for this part. So we have connections here. We'll open the contacts and we can see we have two contacts are there. Now if we want to see what context directly is there applied, we can rename on the basis of definition. So we'll click here rename based on definition. So we can see we have two bonded contacts are there. And here also we can see the type that is bonded between these parts. So as they are welded with each other, so we want to maintain that to be in bonded contact. So we are not changing the contact type. Now further, let me refine the mesh quality. I'll go to sizing and let me refine some resolution value. Let me take this to be 5. Regenerating a mesh. Now I want to make more refinement near the contact regions where that two parts have in contact. So I'm going to apply the contact meshing for this part. So we'll go to mesh again and we'll take contact sizing, and for both side I want to apply, so I'm taking two contact sizing here. So one by one we'll select one in this and we'll define what should be the size of element we want to take into that. Let me put 5 and I'll go here for the second and define the contact sizing and defining the element size of 5 mm, and now I'll regenerate the mesh. So what it will do, it will be refine that meshing near the contact regions. Okay, it will be making more smaller mesh near that regions. Okay, now we'll apply the boundary condition. So I have a fixed support that is applying on that upper part. So we'll take fixed support, we'll select this hole and apply. Now we're going to define the force value on both the rollers. So I'll go and define the force. So I'll taking two force values for both the parts. So I'll define this face and we'll apply in negative y direction. So we'll change this to component and we'll define that should be minus y direction, that is 28,000 Newton value. And second side also I'll go and select that face, apply, we'll change this to component in y direction minus 28,000 Newton. Now we are going to define what we need to calculate. So we'll define here, I want to see the total deformation and I want to see that von Mises stress, and we'll calculate here. We'll click on the solve button. Now it is calculating the results. Now here we can view the total deformation over the model and we can observe how the model is changing, and we can notice what is my total stress is coming over the model. So here 76.308, that is my stress value that is coming right now over that model. And where is the maximum and minimum values I want to check. For that we can use results, and here we have maximum and minimum prop. For that we'll stop animation, and we can see it will show you the area where you have maximum stress and minimum stress over the part body. Same way you can check for the deformation. Now I want to view the results in different form. We have here some option to display the results. We'll go here and we'll take no wireframe view. So where you can view the results in the no wireframe view like this. And we'll go to stress and we can check the stresses behavior in no wireframe view. Now I want to see other methods. We have show undeformed model wireframe. So here you can see the wireframe structure of actual model and the changing shape from the actual position that we can observe here in the wireframe view. Similarly, we have one more option, is that undeformed model. Okay, we can see that undeformed model and the deformed model together. We can play the animation. Then I want to see the same in back to the element view, so we can click show element view. Like this we can see all the results in different way. Now I want to generate the reports. Okay, before generating a report I want to add all the images to my report. For that cases we'll go to individual part. Like by default geometry image will become, so you can set how you want to take your geometry image. Then what other images you want, you can go one by one and you can add figures on that. I want to add a meshing details, so I'll go to mesh and take here in the images and we'll take figure. Then we'll go for like fixed support I want to show, so we'll show the fixed support image. Then force value I'll show in image, and then let's go for this second force. So I'll add okay, this is added. Let me go and add image. Then we'll see the results part, and again we'll add a figure, and for stress value we'll add a figure. Now once we added all the figures that we require to see in the reports, after that we can generate our reports. In the home tab we have that option report preview. Okay, so we'll click here report preview. So it will take little time and read all the data and generate the report. Now here we can see when we have worked on that project, on which date and which version we have used. So this is the model image, and then what are the content is covering in this report, that all the contents we can see. So now you can see one by one that content, like unit details, then model details are there. That model is made imported model, and that is imported into space claim, and the type of analysis, that is 3D. Then geometry details we have. So which units and all we are taking, what is the length, width of that model, what is the mass, volume, and how many elements, nodes we have, that all details it is given here. Then coming to model parts, you can see other details again in more detail, moment of inertia and other details are there. Then you have coordinate system. If you're taking any coordinate system, you can see the details here. Then connection details, we have the connections, we have defined the connections, so that is fully defined, it's showing there. Then we can see here one by one all the details. So what that type of contact region that is bonded, and with the object names we can see the type of contact definitions that we have applied. Then meshing details, whatever we have changed in the meshings, that all details we can see the mesh details. So these are the meshing details and meshing image. Then whatever we have done in the static structural part here, the forces, the boundary condition that we have applied, that all boundary condition details we can see here. So here you can see the force we have applied over that part, and then we have applied that fixed support and other details that we can see by images, and we have graphs here. Then what is the solution part, how much software has taken time, memory has consumed by the software. Okay, all the details we can see, and we can see the result part, what is the minimum maximum result value of that we have calculated, total deformation and one mesh stresses, and then finally result with images. Okay, and here we have the complete details, and then what material we have used, all that material details are there. You can also transport this report into Word or PowerPoint from here if it is required.